Welcome back to this unit on Chapter 10, Quality Control. As a refresher from the previous chapter, we're going to be attempting to answer the question, is the process in control? We're going to be using a case study, and the case study will be my future steakhouse, Duluth Super Steakhouse. And we know that the customer requirement that I'm trying to meet is that each steak is grilled to each customer's satisfaction, and the measurement is going to be the internal temperature of a sample of steaks. So in this part, we're going to go through a simulation of pulling a sample of steaks and taking measurements and then doing the control chart. So when I do this simulation in the classroom, what I do is I have 4 decks of cards that I give out to students, and each deck of card has standard cards in it with the exception of the face cards like the Jack, the King, and the Queen, and the Ace. And I have the students go through and shuffle the cards and then randomly select 7 cards out of each deck. So in this example here, I have, in the privacy of my office, taken the decks of cards and did what the students would have done, and each deck represents a different day of the week in which we are conducting the measurements. So for Monday, pulling 7 steaks at random and sampling the internal temperature, what we see on this slide is the value of the face card. So there were several cards with an 8, a couple with a 5, one with a 9, and one with a 4. Now each of the numbers on the face cards is going to correspond to a specific internal temperature. So all these steaks should have been cooked medium, and the internal temperature of a medium steak should be about 150 degrees. So the conversion of the cards to internal temperatures is shown right here. So, for example, an 8 would represent an internal temperature of 152 degrees. So this ranges from a 2, which has an internal temperature of 146 degrees, and 10, which has an internal temperature of 154 degrees. So I'm going to go back to the previous slide. This is the sample that I have selected. So our sample size, little n, in this example is 7, and big N, the number of samples, is 4. And we're going to convert each of those to a specific internal temperature. And then we're going to calculate the control limits. We're going to do an X bar and a range chart, and we're going to plot the data and determine if the process is in control. So again, the variable little n is 7. There are 7 measurements in each sample, and the number of samples, or big N, is number 4. And also we're going to be creating a 3 sigma control limit, which means the Z value in our formula will be 3. So I've taken the internal temperatures, taken the cards, the values of the cards, converting them to the internal temperature, and they are shown in this slide here. So for Monday, the average of all the steaks that was cooked in this sample, the X bar value is 151, and the range, the difference between the highest and the lowest value, is 5. And we see that our internal temperature for Tuesday was 141, Wednesday it was back to 151, and Thursday the X bar value was 153. Now, if you're not sure how the X bar and the range values are calculated, go back and review the previous unit of this chapter. So the X double bar, which is the average of the X bars, So 151, 149, another 151, 153 divided by 4 is going to be 151. And the value for R bar, which is the average of the ranges, is going to be 5. So now I have these calculations done. So now I can insert them into our formula. Now, for all the control charts, there's 2 sets of formulas for each control chart. There's one set of formula when the standard deviation of the process is known, and there's another formula if the standard deviation of the process is unknown. So since the restaurant is just opening, we do not know what the standard deviation is of the process. And so we will therefore use the formula that is shown on this slide here. So the upper control limit is equal to x double bar plus a parameter A2, which comes from table 10.3 in your textbook. And in that particular table, we have to know what the sample size is, little n. So we go down the row to 7, read over to the column for under A2, and the value that appears for that row and column is 0.42. And then we have going to multiply that times R bar. And the lower control limit is the same calculation, except we have a minus A2 and R bar. So we're now able to calculate the upper and lower control limits with our data. So our X double bar is 151, the R bar is 5, and we'd already talked about what the A2 value is. That was 0.42. So completing the calculations, my upper control limit is 153 degrees. My lower control limit is 149 degrees. So now that I know what my control limits are, I can draw the control chart and plot the data on the control chart. So the upper control limit is the upper horizontal line, 153 degrees, and the lower control limit is the lower horizontal line. And the data that I'm going to plot is the X bar data. So the X bar data for Monday, and then Tuesday, and then Wednesday and Thursday. Now, there are some students who get confused when they get to this point in doing control charts. And what confuses them is they're not exactly sure what data to plot once they have their control limits. So it basically goes like this. If this is an X bar chart, the data that I'm going to plot is X bar data. Remember, X bar data is the average of the data in an individual sample. Now that I have the data plotted, the X bar data plotted, I can look at the data and draw my conclusion. Well, Monday and Wednesday very clearly show that they fall between the upper and the lower control limit, which is what is the usual indicator for a conclusion of in control is, but Tuesday and Thursday kind of fell exactly on the upper and lower control limit. And so from this information, sometimes we have inconclusive results, and that's what we have here. So because the fact that 2 fell within and 2 fell on the line, I really can't make a clear definition, yes or no, whether or not the process is in control. I need to do another test, and what the test I'll do is take a look at a range chart or maybe even do a run test. We'll start with the range chart, see what the range chart shows us. So remember, the range chart is looking at something different than what the X bar chart is. So maybe the range chart can give us a little bit more information on what's going on with the grilling process. So this is the formula here for the control limits. This is what we've gone through before. Now we have to do a range chart, because the range chart is going to be looking for something different than the X-bar chart. So the formula for the range chart is shown here. This is if we do not know what the process standard deviation is. And again, we're making that assumption since the restaurant is new. So the upper control limit is equal to D4 times R bar. Lower control limit is D3 times R bar. Both the D3 and the D4 are control factors that are going to come from table 10.3 in your textbook. Again, that's table 10.3, so you may want to take a look at that. And what determines the value of each is the sample size. And the sample size in this example is 7. So we go down to n equals 7 to that row. I'll go over to D3 and we pick up a value of 0.08. And for D4, we pick up a value of 1.92. So in the next slide, we're going to insert these two values for our D3 and D4. We already know what R bar is, and we'll go ahead and calculate our control limits. Now, we need to do a range chart. So the formula for the range chart is shown here. The upper control limit is equal to another parameter, D3 times R bar, and then the lower control limit is equal to another parameter in that same table, R4, and times the R bar. So in the range chart, the upper control limit turned out to be 9.6 degrees, and the lower control limit is 0.4 of a degree. So now, having known the upper and lower control limits, I can plot my control chart, plot my data, and draw my conclusion. So I've got my control limits of 9.6 degrees and lower 0.4. I have my data here. So the data that I'm going to plot in a range chart is the range data. So the range for Monday is shown here, it was 5. The range for Tuesday was slightly higher, 6. I can see that all of the data points do in fact fall within the control limits. So therefore I can draw the conclusion that the process is in control. So I did 2 charts, and I can see very clearly with the range chart that all the data points fell within the upper and lower control limit. There is variability in both of the charts. We know that there is always going to be variability. The question is the variability the result of randomness, or is the variability the result of some assignable cost? So since the data points fall between the two control limits, the variability is the result of randomness, and therefore the process is in control. This concludes this part of this chapter, and please continue to the next part.